Wait a few seconds for some more people to come. Okay, welcome to this radical, the meeting about it. To this radical collaboration session, I have been asked what that is, and I even cannot answer this to you, but like you just asked me what's the topic. Well, the topic is whatever you decide is the topic. And I interpret radical collaboration. So if you don't collaborate with me, I will become radical. I don't know. So I hope nobody's becoming radical. But let's. What we want to discuss is agricultural adaptation and mitigation pathways and limitation. And this is I guess, a very integrative and interdisciplinary topic. So I would be curious first, what disciplines you from? So whom of you? Whom of you is about livestock? Working on topics.
I do work on livestock.
Livestock. Okay, so at least we have one.
More on crops, though, but I work on livestock. Yes.
Yeah. Okay. So that's the next question. Because I mean, okay, livestock. So we have livestock a little bit covered also when it's about mitigation. Who is working with crop models or crops in general? So yeah, also maybe the majority. Christoph is maybe the most prominent crop modeler here. Or one of the most prominent. Okay, and then we have also the IAM, the integrated assessment part. Who's working with these kind of models? 1, 2, maybe also a little bit, 2.5. Okay. So, and that's I want to give you a short introduction, like about different topics this is about. Okay. So first, I want to talk about adaptation, and I split it into like the management things, and then the integrated assessment things. So what is possible adaptation on the crop model side? So for instance, we had a TGCMI paper on sowing date adaptation. That is something that we already tried to capture in our crop models. Of course, there are also many more studies about this, but all the studies show that it's not as easy as maybe one could think. But that's an autonomous adaptation. So farmers autonomously usually shift their sowing date when the climate is also warming, and that's why we need to consider that in our models. Then that's a paper I have been leading also within TGCMI. That's about variety adaptation, and also this paper showed us several lags. For instance, we don't really know what varieties are used worldwide, which makes it difficult to also implement that in our models. But we identified like a high risk of adapted, of varieties we need in the future that are adapted. Then Frankie et al. Also showed, it's also in part of the crop modeling part, showed investigated in a study how we can shift our regions. Also, this figured out is not an easy thing because of like higher risk of, for instance, late frost events and other limitations, also photoperiodic limitations if you move further north. There's an example for the US. So there are a lot of problems we identified already in these papers. Then I didn't add like, of course, there's always a lot of studies, but that's just the studies within also within the TGCMI. Then there are also a lot of irrigation adaptation studies available. But that's something it's a management issue, so that's what we try or can also consider in our crop models. And of course, many more. That's just an example. What is adaptation in the integrated assessment model? So if you go further, just not on the management side, but also the further supply chain, we had a study also like that used TGCMI results and integrated this that to the MAGPIE model from Bakker et al. That used on land use change and reallocation effects under different warming scenarios. Then there's, of course, focus on trade. How can trade patterns mitigate or actually adapt to climate change losses? That's a paper from I don't know how to pronounce, Bajai et al. We had a paper together with Anton Orlov et al. That looked on labor losses because of like the heating effect on the field, like it's getting too hot on the field, and so how can we adapt labor work hours? Then, of course, land use expansion. I just because I don't have like the overview. Of course, I'm sure that there are also maybe some studies existing about land use expansion. I participated in a land expansion study last year, but that was not within AgMIP. That's why I didn't mention it here. Land use intensification. Also, irrigation can be considered in the integrated assessment models, for instance. So and many more, but that's like just a more or less random, but maybe that's the most important things that integrated assessment models can consider for adaptation. What has already also been done. So, and then moving from adaptation to mitigation, again, first starting with the crop models. You can do climate smart agriculture or conservation agriculture. For instance, implementing minimal tillage in your models. You can look into crop rotation systems, something we also discussed this week a lot. Different crop residue management, as we see here also on the test sites of the simulated test sites. We've seen several experiments with that. Then, of course, if it's about mitigation on the field, a focus is on soil carbon enrichment. How can we enrich soil carbons in general? So there are many different ways. I just pick randomly because it's very interesting. Biochar application has a very high potential because it has a high area, potentially huge areas, like per hectare. The GHG removal rate per hectare is relatively low, but because you have so many potential areas, the potential for biochar application is really high. And this is like on the other side of this graph, it's about peatlands or wetlands. That's just very small areas at the global scale, but they have a very high potential for GHG mitigation. So if you don't use them for agriculture anymore. Also, rock weathering is something that is a relatively new thing that also needs to be investigated more. You use basalt rock that can take up the carbon when it rains, and then also bring a way to bring carbon into the soils. So that's two very interesting things. I don't know if any of your crop models are already like able to capture these processes in the soils that are important for considering these different possible mitigation managements. Or just maybe just as a first question to you also, is there anyone who is capturing or who has studies about or who's doing any research about biochar application or rock weathering? Not so far. So also maybe something we can later discuss if that's something we need to consider more. And then besides, of course, the agricultural production, I didn't list livestock. I concentrated only on the crop production before. But when we look at the total emissions of the food system, we see that land use, transportation, packaging, crop food waste, and so on consider actually contribute to a lot of the total emissions. So, and that is part of the integrated assessments model. So considering land use change, food waste, and of course diets, as we heard in this very impressive talk with also the new Eat Lancet study.
Can I ask, when you're speaking of land use change, there's complete land use change from different, from annual cropping to pasture to forage, annual, that kind of thing. But what about crop rotations? Like the crop rotation diversification is quite a big field.
Exactly. I think crop rotation mainly is more a part of the crop models, and that wasn't. I don't know if integrated assessment models have crop rotation included in their.
Some mimicking some elements through certain constraints.
Yeah.
In a good cell, you can only have an upper share or something, but in very simplified version.
I just find there's such a huge difference in the performance of crops with and without crop rotation.
Exactly.
They perform better with crop.
I would categorize crop rotation more to the management. Like I would list it here. Here's our crop rotation is like it's very small, but like part of this management thing. But it's already
Okay, then with climate smart management, there's probably about 30 practices.
there are plenty, but
Yeah.
I wanted just to give you some ideas, not a
Sure.
full capture of everything.
Okay, well,
Yeah.
thank you.
Florian, sorry, but just to add to that, I mean, crop rotation is one thing, but multi-cropping and intercropping.
Exactly.
It's
Those are
elements which are not well covered. Right?
no, those are being worked on by some of the AgMIP teams, but or they may be.
Yeah, exactly. I mean, there are many things I didn't explicitly list here, but
Okay.
one could complete this list with many more aspects. But when we talk about mitigation and adaptation in general, I mean, there are a lot of like individual studies that I showed you there with the papers that I showed you already. But it's also about combining different aspects and try to identify co-benefits. For example, for agroforestry, there are a lot of different co-benefits, and not only co-benefits between adaptation and mitigation, but also beyond that. For instance, biodiversity. That is also in this example in agroforestry systems an important aspect. And water regulation and so on. So what are the questions we want to address here? First of all, we want to identify existing AgMIP activities. I tried to capture already some that I know, or also ask you what work are you doing actually? What are the most recent advances in this field, mitigation and adaptation? And then we want to ask specifically, how can we implement adaptation and mitigation in our models? Because actually there's a lag, obviously, in considering these things. How can we combine measures for adaptation and mitigation for identifying co-benefits? I think that's really important. And maybe this is maybe also good that we have like people from different disciplines here. How can we integratively combine findings from crop models and integrated assessments models? So combining adaptation and mitigation, not only on the crop model perspective, but also develop maybe scenarios that are consistent between the crop models and also an integrated assessment models. Another question that came up when I just discussed also this just before we met here, is geoengineering also an option that we want to consider for adaptation? And then what challenges are needed to answer these questions? Or maybe you also have additional questions. Do we need partnerships? How can we overcome barriers to progress? And what new AgMIP activities are needed to enable progress? So, but if you have also other questions, you can also come up with other questions and ideas. Okay, so let's start here. Yeah.
Just to be clear, so are these questions to IMs, global economic models, global crop models specifically, or
No,
talking about subnational models, crop models?
Of course. Yeah,
Okay.
of course.
Or like the one.
Yes,
so
that's what I was wondering too, Lucas.
I think we have the same question.
Yeah. Okay. Yeah. I mean, I think that generally for integrated assessment models, because they work usually at the global scale, it's difficult. Herman, you maybe can help me also with that. to use very regional inputs. So I think that's a general problem. But maybe there are ways also, or maybe I don't know. You want to add something to that?
Yeah, first of all, just for clarification, because you mentioned engineering, what do you mean by engineering? Geoengineering, because that's a pretty broad thing.
Yeah, as far as very geoengineering for instance, what
Vertical farms.
vertical farms. To me, vertical farms are not. Yeah, I didn't thought about vertical farms of geoengineering, more for like
Very high.
like
Are you talking crop adaptation or drainage and irrigation or?
actually, yeah, I discussed it with Jonas. He actually should lead the session with you. So I would have asked him now what he meant with that, but he said I should add that also for I don't know what he meant exactly, but I think he referred mainly to some maybe sulfate
Aerosol?
yeah, some
Aerosol loading. Yeah.
aerosol loading, maybe something. I think that's what he mainly had in mind, but I'm not sure.
I mean, there are certain things which are
Yeah.
in the IAM models now, like direct air capture, like enhanced weathering, which may be related to agriculture, where you then have to spread these minerals and so on. You can also, of course, talk about solar radiation.
Yeah, solar radiation.
I'm not sure how relevant this is for today, but there's a couple of things which are being.
Yeah, I mean, biopower application and rock weathering may also be defined as geoengineering. They're maybe different.
Yeah.
Can I come back to those comments? I want to understand what the objective is when you do the global gridded modeling in terms of adaptation. In terms of mitigation, I can understand you want to estimate at the global level mitigation potentials of different technologies or practices. But adaptation, when you go on a global level, if the first slide that you showed, and you want to say something about planting dates, what is the objective of that? Is that's I am not understanding, because as an agronomist, we use crop models and we want to test planting dates of varieties for a specific region, a few farms often, and then discuss the results with the farmers. So, but here I don't.
Okay, yeah, the purpose of these global,
difficult if we have different, if we don't explain our objectives very well.
Yeah, I think for the global scale, maybe Christoph, you wanna also say something? What was the purpose on the global scale? I think we are looking mainly on adaptation possibilities for the future, because when we just assume static management, that's not realistic in our future climate impact scenarios. So that's why we think we need to have a kind of consideration of an adapted management, that because the farmers do that autonomously, they will not keep their management static in the future, and that's why we figured out how can we adapt sowing dates, how can we adapt or use adapted varieties, or potentially shift regions. But we did never combine all these different things. So that's kind of isolated studies. And I think what would be needed was also a combination of different adaptation possibilities in the models, to also see by how far we can adapt. Maybe Christoph first, because
I think at the global scale and these long-term projections of what crop productivity may be, right? It's maybe because we do just a few scenarios. And so far we've done the super dumb farmer scenario, which is they do exactly the same as they did 100 years ago. Back mentioned, and that's not realistic because farmers autonomously adapt. And that's a job, right? To basically think about what they could do better if this is changed. So for the sowing dates, we basically just have a rule-based approach that kind of considers when does the growing season start in terms of temperature and precipitation thresholds, and shifting that. When does the growing season end? And kind of that would require new varieties. And you can make assumptions which are crude, but which are better than assuming that nothing changes at all. as a function of the climate science. But I think for this session, we shouldn't get hung up too much on what the global scale things do, but the interesting question is really, how do we, as a radical collaboration, how do we understand the interaction between adaptation and mitigation, and between an economic perspective of things and a biophysical perspective on things and a social perspective on things, and whatever perspectives we may have, that may very well happen at very local context. And ideally, that very local context insights can inform the regional context inside and kind of do something there and learn something again, and that can inform some global and the other way around. So it should be a cross-scale learning exercise. I think that would be a more valuable discussion than us justifying what the global scale people do and stupid assumptions. I think that's not the idea. I mean, I'm happy to explain more of the things that we did, but I think that gets us on wrong track for the discussion.
Yeah, Hermann, you wanted to reply.
Yeah, to add, but also come back to this connection between the different scales. But can you go back to this, to a nice photo with the combine harvester? I'm a farmer boy, so I love this. This is a good example, right? I mean, this is a production system, agroforestry, maybe in this type, and you have crop production and you have the trees with carbon storage. And this is one of my favorite examples in talks, about co-benefits. Now, this needs first to be described and understood in a concrete local context, or ideally in several different local contexts, saying like, okay, under different climate conditions, such a system compared to the standard pure cropping system, what are the effects? I mean, what are the yield effects under changing temperatures, whatever? How much carbon can be stored permanently in the tree rows? Just describe the system from the biophysical view, inputs, outputs, so on. And what are the costs? How do ideally, from my perspective as an ag economist, how much more expensive is it? But also how much more do I get out of it? So describing this production system compared to the standard just grain field. And that's already a task for cooperation, I think, between different disciplines here. And then I think there's a very pragmatic way to upscale these things with the global models. We have done this with several things. Just taking, okay, if you tell me that this technology or this production system works in this way, and then we just we pretend, what if this could be scaled up to XYZ% of the total area? So that's a relatively pragmatic way to link those scales, and would be really, really interesting.
Yeah. Something that we've been doing in AgMIP, in all our regional integrated assessments, is thinking about adaptation, not just agronomic changes like planting dates or varieties, but instead in terms of adaptation packages, right? That can involve markets, policies, and all those aspects that will enable that adaptation strategy. So that's the way I see it. How we can connect better, for example, with the national level or global level. The other thing is, because when I saw the title, Adaptation Mitigation Pathways, right? That's kind of linking to scenarios. I mentioned in the global economics session that we had, there's this new initiative to develop what they call global adaptation pathways, right? That is kind of following the SSP concept for all the sectors. That's going to be one specific for agriculture. But the idea is not looking at the planting dates or all that more farm level decision. Is more about how the countries can invest in technology policies that can enable farmers to adopt, and then how can we bring that to the global level. This is an initiative that is just starting, but I think in the future that would be interesting to collaborate with the global economic team, because we will have the scenarios in terms of adaptation strategies at the global level.
Sorry, I will add, it's not just regarding planting date, but I did a publication in 2020 in Stoughton, which was basically about looking at all model processes, or not all, but a number of model processes, in fact, which are required to simulate the impacts of climate change. Absolutely changing, and planting date is is required, and we included that in the model we developed. But also things like changes in fertilizer rate, absolutely required. No sense doing simulations in some regions if you don't do that modification. Just something to mention. And continuous simulation with the feedbacks is also required in the soil CNN process.
My point is just as Robert said, I think we put a lot of our focus in agronomic. I'm agronomist, by the way. I like it, but looks like our focus is more in that aspect. And so far, market and policy, those two might have been a bit less emphasized in about the adaptation and mitigation packages. That all, I also have that very strong feeling here. For example, let's say we say that is the fertilizer rate, this is the planting rate, everything. But if there is no market price, then adoption will go in next year. They will not be adopting, they will drop immediately. That is. And to promote adoption, actually, that I was sharing my thought in other meeting as well. My idea is incentivization. That is lacking in our system. Incentivization does not mean giving money, cash money like this. That is performance-based incentivization. For example, let's say rice yield in West Africa is average rice yield is 2 tons per hectare. Then maybe some sort of incentivization mechanism. For example, if farmer plant rice in certain area, we should not say that everywhere, or let's say 400 meters square, that will not qualify. Let's say some farmer plant rice in 5 hectare or significant area. And if he has, let's say, more than some certain threshold, and if he cross, and then if government or some sort of support that farmer gets, then there will be, I'm sure this kind of adoption will be boom. That I actually, when I was in Ivory Coast, Africa rice, I made that calculation again sometimes. Ivory Coast was importing rice of around 300 million that time, 300 million. Then if we spend 30 million only per year, country will be self-sufficient. 300 million will not go to Vietnam or any other country from where they are importing. And then all self-sufficiency and all those objectives will be met. My point here is policy. Anyway, this is policy performance-based incentivization type of policy, which encourage farmer to produce more using less or using sustainable practices, AWD, good weed management, better mechanization, good planting rate, anything, or package. I would say package. Package is it should go in package. Yeah.
There was another.
On the livestock piece, I wasn't clear what you were planning to do there. And when you showed the soil carbon sequestration options, and some of those relate to improving livestock emissions also, like grazing and grazing land management, for example. But there are a whole lot of other things that could, be considered both adaptation, mitigation, and animal husbandry. That I just don't know how your models represent those, or if that's a priority. But to me, it would be like improving animal health, genetics, feeding, including on grazing lands. Like, I don't know how well the models represent, in a dynamic sense, grazing lands. Like, if one was to change the practice and increase forage utilization and quality, what does the model show, if anything? And how would that then flow into methane emissions resulting from the digestion of that high quality forage? And then the other thing I'm not clear about is the crop livestock interaction. Like, if you were saying, certain scenarios like beyond the dumb farmer, which might be certain thresholds for types of crops when they could grow, etc., and what biomass production potential there might be under certain climate scenarios of different crop types, which of those crops are more suitable for feeding livestock in terms of their residue? Like, what's the connection between the crop and livestock world and your models? that would seem to me another important link to be making stronger, if not already.
Yeah, this is very
Yeah, thanks for that. And I think I have a procedural suggestion. You already started that, so that's why I refer to you. I think, as this is a collaboration session, and we're kind of throwing in lots of ideas and kind of our own perspectives. I think what would be really valuable if you say, I'm interested in livestock and what that means. And for that, I would have to get information from group A on aspect B. Like if you can, like you say, you would want to know what's the feed quality of residues, how does it change? Like, is there any group doing that? I would be interested. That kind of, and I think that would be valuable to collect that, and I try to take notes for it for the reporting back, but also to basically see, okay, these are questions that are relevant to people here, but they have information needs where they may not even know where that should come from, but or maybe they think the global economist should tell me whatever. And then we can kind of see if there's a match either in topics, like you needed information and you want to supply it, or a mismatch or lack that we can then try to fill this back. And that would be useful.
Yeah, I mean, in terms of collaboration, livestock is generally an issue. I'm not sure how many active livestock models we actually have in I don't know. Are there any in the room? Yeah.
Well, yeah, in the regional integrated assessment, we had a livestock component. We've done that kind of analysis for Zimbabwe. We had another for Tanzania and Kenya, and looking at different feeding strategies and how we would use methane emissions and using also different breeds. But I agree, we need more livestock modelers. We've been talking to other people. Let's see if we can add more, but that's a component that is
because it's similar at the global level. I mean, some of the global land use models, like our model pick and the global model and the JASA, have quite a bit of these dynamics in there at some level, different feed baskets for the animals, how it affects productivity and the emissions, the interaction between grazing intensity and the feed balance and so on. So that not so much on genetics, I guess, right? But yeah, one could look into more detail there. But this is not so much about adaptation mitigation. I think this is more in terms of mitigation scenarios.
Right. At livestock, if you're unable to manage your forage in time and space, you run up against the problem of having too many animals and not enough feed, which is an adaptation problem as well. So it's kind of all mixed together.
Yeah, that's right. Although in the deep mitigation scenario, you have lower number of animals anyway.
Because the models don't allow you to model the management. So your only option of getting the emission reduction is increasing animals, right?
No, because you're
What else can you model?
Well, because you run into limits, you can only improve the management so much, but you don't get down to enough with the actions. We can disentangle that.
Yeah, okay.
So I have a small question on the figure that you have shown on mitigation. The figure that you have. I'm just wondering, for example, some of those practices that you mentioned over there, are they not good to include in the modeling practice? I would prefer to kind of pinpoint the individual practice, and then later on bundling would be something, but it is very essential to quantifying the mitigation potential of specific practice. For example, cropland management, to me, it means anything, whether it is a tillage management, residue management, fertilizer management, or weed management, water management. Everything comes under crop management. And rice management and water management, it might be coming from different papers there, but to me, mitigation potential of water management is mainly rice water management. And then, rice management, it's again crop management. There are mitigation potential of different tillage practices for rice system. There are mitigation potential of different fertilizer management within rice production system, and there are mitigation potential of different water management system within rice, right? And then combining all this in a bundle way had a different mitigation potential. So at a modeling level, at least the way that I would quantify is what would be the mitigation potential of individual practice, model that, and then if that practice or that potential would be increased if you add another mitigation options in to the bundle, for example. So that would be the real value for farmers.
So you want data from experimentalists on individual measures,
Yeah,
and you want modelers to combine them in their model to see the overall potential.
yeah. And then there are data here and there, and if we really collaborate that, I think that there are possibilities.
So yeah, you want to do it next?
Yeah, well, and that, I'm glad you went first, because I was actually gonna say something about that, but I was just gonna talk about livestock as an example, because I'm not a livestock model. We do work with some animal scientists, but we did a paper in the US where we looked at beef mitigation solutions to do a life cycle assessment, and we came up with, I don't know, 30 some different things that you could do to see, yeah, how much, what's the mitigation potential in these systems, right? And yeah, we're thinking everything from including life cycle crop stuff, but all the way up to pre-op and vaccines and things like that, right? But I think my point was, and this is what I was learning from your talk as well, and Sonali, you were talking about, and Roberto, actually, I was mentioning this to you, is like, it seems like everyone here at different scales and different places has different solutions that they're applying both in the adaptation space and the mitigation space. And for me, like, I know when we're doing a study like that, we're trying to be comprehensive, but we're not, right? Because, we have the local expertise and the knowledge and the specific solutions that we think we're doing. It seems like since this community is trying so many different things in so many different regions all over the world at different scales, just knowing what the options are, and to a point, then to your point, like figuring out which ones have data, which ones don't, which ones we want to test, are there interaction effects that's useful. But I always worry that we're, at least in our taking a very regional and discipline specific perspective, that we're not capturing important solutions. So I was like thinking about, I know Sonali, in your presentation, you there's the Project Drawdown is one initiative where they're basically trying to capture different solutions you could go through. It's almost like a solution database, right? It seems like you could almost have an AgMIP solutions database. Either there are different mitigation and application strategies we're trying everywhere that we can learn, and which ones we're doing, which ones are not. I mean, another one that we're trying to have a project in the US, we're doing agrovoltaics, right? We're taking, which is similar to the agroforestry, right? Except instead of trees, you're doing solar panels. So you're doing solar panels and then you're growing food, right?
Yeah.
But there's not a lot of data on that, right? So that's just one example that we're doing that some other folks might, but I only know about it because we have a project we're doing on it. And there's all these other solutions that I don't know. And since we're looking at mitigation, like I don't have that matrix that shows which one are also potentially adaptation solutions. Some of them probably are, but we haven't done what you did, which is like put those side by side, right? Which I think is super valuable. So I feel like for me, the learning is just learning what everybody else is doing and what they're trying, so that we can start to think about, well, is that relevant, what we're doing and where we're doing it, so we can build out. In our case, we want to build out the adaptation side, and we're stronger. We're not doing that at all, and we want to. So
you want someone to do a literature review with the database and adaptation options, so that
I mean, I guess I'm thinking less about literature review, which would be, but I'm thinking more like, even if we're in a space like this, even if I were to say these are the solutions that we're doing, is anyone else doing these? So we could harvest our own solutions that we're trying in AgMIP, right? It's almost like a solutions and comparison project.
Collaborate to get an overview of what people are working.
Yeah, and then to your point, then you can think about packages of things putting together, in the policy scenarios and the SSPs and things, which is great. But it seems like there's so many different solutions people are thinking about. It seems like a thing we could mine within our own community to learn from each other.
Okay, sorry. Well, so I am a full farm system modeler, but I focus mainly on cropping systems, probably 90%, but I do grazing and also farm facilities. So these are things like emissions from manure storage and digesters, composters, and barns, as well as the livestock. A person can only go so far in a project, but all these processes, if you want to look at different farms and farm architects, are all important. We have lots of projects on that right now. So just bringing it up, how far a person wants to go. That's going away from the cropping system side totally, if that component was added.
In how many locations are you doing?
Pardon me?
In how many locations are you doing that?
We're doing that in one project in 34 locations, but it's only in Canada. So most of my studies are in Canada. Yeah. Yeah, but I don't know what anyone else is doing, you know.
A few people mentioned about the literature, and so this paper that's now in front of me, and I couldn't see it in the paper. You listed here a global data set for the projected impact of climate change, and this is included like literature scan, and they reanalyze the data of all previous study from 1985 until 2020, and which include adaptation and mitigation. But unfortunately, most of the studies are about fertilizer and irrigation, and those two cannot be adaptation, maybe. This is one of the things, so I think this is what you suggested, is like a dual literature scan, because there's a lot of studies done in like this, and the data can be taken and analyzed. The other thing, yesterday when we went to the long-term trials here at CIMMET, we saw some plots applying conservation agriculture since 1990. When I asked whether they have measured the pH or the earthworm or things like that, it doesn't. And today I visit one of the office. There is still the data there for many years, but they haven't compiled this data yet. So I think this is one thing to look at the trend of what has been changed. We have in the UK in Rothamsted, it wasn't an intention to look at the climate change, because concerns about climate change that time when this trial set up wasn't exist yet. Some of these plots is being changed from like cereal to legumes to then grassland, and now they're looking at these long-term experiments. So the results of these long-term experiments, such as here in the CIMMET, in the Rothamsted, also these data can be taken and be added.
Thank you. Maybe also, we also had this discussion in TCMI that adaptation and intensification sometimes is mixed, and also often it's not really clear if people mean adaptation or intensification. But of course, there are, like, I would say there are also dependencies between it. If you intensify or have in high intensive regions, usually because you have all the infrastructure, usually you have better adaptation capacities actually also. So that also there are a lot of dependencies in between. Okay. Yeah.
I think you had your hand up.
You had it for long.
Yeah. I was watching it.
What was the paper that you cited just now that you were looking at? You said you had a paper in front of
A
you.
global data set for the projected impact of climate change on 4 major crops, and they're using AgMIP data as well.
Okay.
So
Yeah. So here's just another idea building upon your idea, but taking it beyond a liver. So, and I don't know that we need to use any one of these papers, but Pete Smith had a paper in 2020 that got folded into the IPCC. And it's sorry, table 17 in this paper is relevant. Which practices co-deliver food security, climate change mitigation, and adaptation, and combat land degradation and desertification, right? And so in this table, you get everything from livestock practices to management of rice to forestry, and even moving beyond the ag sector into the forestry sector. And a couple of things popped up in this paper. It was pretty comprehensive in the number of strategies they looked at. What popped out as of 2020 is that the evidentiary basis for a lot of this was pretty new. The uncertainties were high. So using that as a potential starting point, one could do a quick evaluative work of what is the evidentiary basis for the scaling potential of any one of these practices, whether or not it has scaled, right? Is there a discussion about it being able to scale, and what are the mechanisms that are being discussed in the literature of scale? Once we have an idea of just those practices that can scale, that might be able to wrangle a conversation of like, okay, I think that AWD can scale in XYZ ways through these policies. And that might be a focused discussion of how to link across the global grid stuff all the way down to the regional stuff, and actually use those two kinds of models to kind of cross-check and validate on each other. For those practices that are super specific and don't actually have an evidentiary basis of scaling, that's not worth wasting our time on it. So it allows us to kind of prioritize where we can start. I'll just say from the rice side of things, Andy McDonald has had some really great arguments alongside alternate wetting and drying that we're not looking at the watershed landscape level flood regimes, right? And we need to be able to incorporate that within landscape level modeling rather than the point-based modeling. And from that, you might be able, what could emerge is a potential, I'm not going to call it suitability, but areas that could be more constrained. I love that idea, and that requires remote fencing and other things. But that's one way to sort of think about, okay, that we have an evidentiary basis of SRI or AWG scaling, but there are these other processes that we can now link up to do. I don't know if that makes sense, but it's something.
Yeah, totally makes sense to me, and I think maybe that figure is about scaling already. So that's why I showed it, and here you can see that that's why I picked this as an example. Biocar application has a high potential for it because it has so many areas that you can apply it.
Sure.
It and also wetlands or peatlands. Not using peatland for agriculture anymore. That's also high potential. Rice management is here. Maybe you can, and there's restore degraded land, water management, set aside cropland management. So that's very general.
Christelle has a map on areas suitable for conservation.
Yeah.
Right. And people have used that in climate model simulations. And so there's and some of this is a bit more hand wavy, global trend, but still it gives us a place to start.
Yeah. To identify focusing maybe on things that have very high potential, and with it, yes.
Okay, I want to make a short point on that builds on trying to find out what measures are worth looking at. I would cross-section this with what can the models actually model currently and how much work would it take to get them there. Because as we know that crop model improvement is very underfunded, no one has time or money to do it. So what can we realistically incorporate, maybe for example for fast track paper, whatever. And my second point is that we should be very careful to separate adaptation and intensification, even though they might be somewhat blurry defined. In my opinion, they're not. If you run an adaptation analysis in the future and you see yields increase, you can call this climate change adaptation, and that runs the risk of disregarding the fact that if you do this practice now, it also increases yields. So in the end, it's just intensification. And I want to make this point because calling something climate change adaptation increases interest, liberates funds, and we should allocate those funds to things that actually decrease the impact of climate change and not just intensify yields somewhere.
Yeah, just a comment on that maybe. In the really good team, we are splitting the link between intensification and climate change. And we call that a non-regret adaptation. So let's say we increase the yield by 200% with intensification with climate change, and with climate change, 190%. So still an adaptation. It's a non-regret adaptation, but still it's much better than not doing anything. So we can distinguish true adaptation versus non-regret forced adaptation, non-regret adaptation. But
not to devalue those measures at all. But funds are limited, of course, and if we communicate with policymakers, climate change adaptation funds should go to actually climate change adaptation, and non-regret adaptation you could fund with completely different measures as well.
Maybe just on your first point, I think I agree totally as well. I mean, maybe models are not ready for transformative adaptation like agroforestry, the cropping, rotation. We still have a lot of work on that to assess what could be the real impact of those kind of adaptations that could help build soil fertility and be maybe very good adaptation. Still have a lot of work on that in academia.
There was one hand there. Right. Was it you? Yeah.
Caleb first.
Oh, okay.
Your point on intensification adaptation, I was thinking, what about the mitigation side? Because there are many benefits of intensification sustainably for mitigation, which might happen more readily and more at scale if the mitigation benefit is added or recognized more than it is now. On the evidentiary basis and in the modeling capacity to do that, I wonder also whether it would be helpful to get like then deeper into each of these practices and say, what are the kind of assumptions that we have about these practices? Because just to say conservation agriculture, what's the mitigation potential of that? Where? In which systems, right? And is there a way to kind of converge on, by biome or system type or whatever, the mitigation reductions we expect from a given technology or practice is this. And that same practice here would be that. And then the models get a lot more like, well, accurate, I hope, in terms of representing the potential reductions associated with those different practices. Because I don't know what assumptions people make. Like people model whatever thing, but where are they taking the evidence, right? To say it's a 30% reduction or 15% reduction, or is there one place people go for that? Or is it just the latest paper that someone finds? Like converging on that, they probably got. So
Is on the question, what can people model? So mitigation, I think the common models like DSAT, STIX, ABSIP, and some others, we can model quite well soil carbon sequestration if we have some data, soil data. And then end-to-all emissions is often a problem. We have done some exercises and it's really a struggle. But again, if you need rough estimates in function of management, I think we can deliver that. And I have no experience with methane emissions. How good models can do that. But so soil carbon sequestration with data, we can do that in function of management. And we can do relatively well. And retain, I don't know whether somebody knows, but that's, I think, more of a struggle. But people have experience in rice, and you showed some.
And then how good the data are,
Yes.
and then if you trust your calibration in relation to represent.
Yeah, Herman?
Yeah, I want to follow on Matt's point. I think that's an excellent point. I have contemplated for quite some while also, and maybe Roberto, you can explain a bit right now with this AgMIP Explorer thing. But for various reasons, I think having a database, just an AgMIP database, who's doing what and where, would be really helpful. I mean, in terms of more radical collaboration or whatever, not only for the insiders who are already in there, but also someone who's coming new, like you say, I'm doing these kind of things, I'm doing this in 30+ sites in Canada, but maybe they're, in different countries. Similar things are going on.
We're also working a little with collaboration in the US and Sweden, I forgot to mention it.
Yeah, no, but just to have, where are we? Who's doing what? And I mean, we have this a little bit. If you go to the AgMIP website, there's a map. I think this is about regional or site-specific crop modeling, right? I think there's a map, a lot of dots, I guess, where people are doing modeling on wheat or maize, whatever, but expanding this on measures for adaptation, measures for mitigation, and you can start with a certain list. I mean, I guess there are already quite long systematic lists, and then if someone comes and says, yeah, look, a specific measure, who is working on this, just as a starting point, and I mean, this could be expanded over time. I don't know how much work this is. I'm not a database person, but I think this would be a
Good idea.
brilliant.
Instead of a lip review, that it would be a survey, right? When I have a survey, I would be one and have people to contribute their solutions and their regions they're looking at. I think the trick then would be the classification system, and people will use different words for different things. I mean, I think it would be a fair amount of work, but it would be useful if you had the end product, right? And you can make a map you can put on the website.
I think really that you have that again for this cross-skill thing. If I as a global modeler look at this and say, look, there are 5 locations where a certain technology is worked upon, and there's even underlying publications with it, or whatever, or teams, then you could say, look, what about scaling up and down? So that would be useful.
We have the impact explorer. It's this dashboard that shows some of our regional integrated assessment results. We have these adaptation strategies that we work in Africa. But there's also another component that goes deeper into looking at the data. So if you look at the data from these projects, but also there are maps that have data from free data from the global gated crop modeling that are already available in this dashboard. Hasn't been updated for quite a while, but it's there.
I guess you showed that in the
Yes.
meeting interview. Yeah, that is really cool.
Just a quick question on this figure. I came in late, so when I made that scaling question, I just closed the meter there. Are these spatially disaggregated and this is just an aggregate view, or like are these spatially explicit maps of the potential?
This shows the soil carbon sequential potential in kilograms carbon per hectare per year for different economic measures, but in total.
Well, I meant the plot, so you've got this scaling plot here.
This one.
Yeah, I guess I'm just wondering, like, these numbers, so I can't see.
Yeah, these numbers are in petagram CO2 equivalents per year.
Right,
And they
so
give you a kind of potential
the
for,
global aggregate potential that's not.
yeah, it's a
spatially
global
explicit.
aggregate potential. Yeah, that's
So how much of this is spatially explicit?
is that Forsten et al. 2016 Nature paper?
Yeah, okay.
And
No special.
Nothing is spatially explicit?
I think that maybe it's just I don't know actually, but
Yeah.
maybe not.
I'm just thinking like there's top-down potentials that like frankly drive me nuts all the time, but it's fine. It's good. It's a good.
Otherwise, we wouldn't.
And then,
do it.
but then there's bottom-up data that we're talking
Yeah.
about. And I'm just wondering, can we like just compare what's out there in terms of potential maps, like CA, and say, okay, for all the places where we have CA deployed, to the extent they're even talking about actual substantive mitigation or carbon, how does that compare to that map? And it's not a modeling exercise per se,
No,
yes, but it builds up to that to say, okay, what are the actual constraints that our models have on those? I mean, for me, I think with the risk, like, yes, potentials, you can spit out potentials any which way, and it's great, it's fine. But what are the constraints? And this group is kind of nicely situated, at least on the biophysical constraints, if we can figure out what our models do to do that. And then there's socioeconomic constraints, on top of that. So I'm just wondering, like, is there a way we can start with some hand wavy spatially explicit maps that are already available and start cross-checking against our site-based data?
I don't know the need. Maybe someone
Yeah.
know.
I can supplement on that. So there are a number of, this is cool paper, but there are a number of other papers, little paper that they have done, but it's not a kind of modeling that we are talking about in AgMIP communities. It's like a scenario building, and then a lot of assumptions there.
Yeah.
Like, you have this, mitigation potential of a practice per hectare, and then, global potential, and then you have kind of an assumption that what is the adoption, what are the potential area of adoption of that technology globally, and then you do that, various special skill, but you finally aggregate from you come to the global potential. And there could be also, for example, you brought the example of conservation agriculture. It could be example of organizing voting and drying, can be example of precision nutrient management, can be example of stopping residue grounding or something like that. So what is the mitigation potential in certain environment? And then what is the total area of that environment? And what is the level of adoption of that thing? So it's kind of a lot of assumption in between, but it's not a process-based model. It's kind of scenario model like that. That's
Just to follow up, sorry, just to follow with that. John Andrew and I did a lot of these type of analysis especially for carbon sequestration. So looking at what is the technical potential, right? Yes, but that's different from the economic potential, which depends on how land use changes, the adoption rates of the different management practices that you want to change to sequester carbon. So there's that analysis that we've done in the past, and we've done some analysis in fact the global as well.
Yeah, I think we've covered the point. People would like to know what options exist and what data are there and what people do sufficiently. I'm very, very skeptical that the AgMIP database would be of any value at all and it would work at all. I mean, there's massive initiatives that try to do a one-stop shop for or things, and before you have a database that people actually go to look at it without just using Google or some other look for what they are searching, that really needs to be very comprehensive, well-maintained database. I don't think I will ever have. I think what the charge to all of us is that everything we produce needs to be fair, findable, accessible, reproducible, and then we can find it if we look for it. I think that would be a much better charge to us than assuming or asking for someone doing a database. I really want to do that in 5 years' time. But I want to, like, if we can park this, we would want to know better what people do, and I already have that as a point. Coming back to the charge to this discussion, like the radical collaboration, what is the collaboration? Like, we all voiced our data needs now, but we haven't addressed this. Where do we want to collaborate? In AgMIP or with people outside AgMIP, doesn't matter, but like that, I think we have like half an hour left. That would be good if you would cover that a little bit.
I would be in favor of contacting NGOs that try to implement these adaptation measures, which we want to model. I know one in Freiburg, I think it's called Biochar, and they do a lot of experiments throughout the world, and maybe even have some modeling experience to see if we can somehow collaborate with them, help them get some data, and they get some exposure, stuff like this. And that's my point.
Here, yeah.
That's not very clear. Collaborate on what exactly? I mean,
Maybe how.
Yeah, on Chris's point, I think we could do both. I mean, being fair and still trying to structure things a bit, but okay, maybe I'm over optimistic. The other thing is if we here talk about collaboration across teams, we also do that all the time, but then you don't have the capacity to actually do it. So it's also a bit tricky. So I just now Sonali's on. I wait until she comes back because I wanted to say something about this. There she comes. Good. I was just waiting for you to come back because I want to respond. Can you go back to this slide with this upscaling thing? I mean, some things can be done with the models we have, right? In terms of constraining potential. I mean, for example, on peatland, I mean, we have done studies, we have spatially explicit maps of peatland, and then we can run a scenario. What if 100%, 70%, 50% of that peatland, and you can even define that from a spatial map, are excluded or are revetted, meaning the agricultural production, which is currently there, has to go somewhere else. I mean, these kind of interactions we do have in the global models. And for some of these other aspects, I know, they're all difficult, degraded land and so on, but this could be done together, maybe by jointly defining scenarios and even combining these effects. Because, I mean, in the global land use models, we have all the major land use types. If you constrain something somewhere, you protect the tropical forest, you re-wet the peatlands, you take some of the other things, you can easily come to a scenario which gets quite constrained, but I think you will get the major story. Okay, can this work, or where are the limits? So I just indicating this could be a way of collaborating to designing scenarios together and then see what are outcomes with the tools we already have.
Yeah, I think maybe that was one of the points that I addressed here. Also, how can we combine also different potentials from the crop models maybe, and combine the integrated assessment models, and also combine like consistent adaptation and mitigation, like define different scenarios where we have adaptation and mitigation maybe combined to get some idea on the impact, on the global impact, actually, also like to have pathways, that maybe what is the maximum possible mitigation of, and what is the like worst case scenario, like then we at least have a range that we can maybe look at and see how we can find pathways and impacts and things like that. I think that's what you want.
Yes, or take Sonali's example, right? When you have to know where the rice production goes on, and then you think about this different type of management with different water consumption or whatever. Of course, that can be scaled to larger areas and see what happens and what are the interactions with other concepts.
So that would be something maybe for the next IPCC that we could contribute to if we would have the capacity. A lot of wood. Institution.
I think no.
Yeah, go ahead. Okay, right.
Yeah, just the point that I would not do anything with geoengineering. That seems a bit, I don't know, like masturbation. In a way that it's cool to think about it, but it would not make sense to really actually do it.
I'll just put in that at the moment, altering the atmosphere is an international crime, so that's not suggested.
Good.
It's a violation of UN treaties on the weather.
Is there any, like, I know it's radical collaboration, but is there any like small, tiny radical collaboration? Grads who might be interested? I might have a grad student, but like just one management. One, like what, I don't know. Just putting that out there. Like, can we start?
It sounds like a really good idea to go small, you know?
Yeah, it's very small.
Who has
50
data?
managements.
So I think that's a good point, personally, and many a times I think it's at these CGIER centers, they do host students to do the research if they want to do research in global south, for example. And we can support providing, research field lab support or recent food, etc. So that if the project matches with the students' interest and professors' interest matches with what project that we are operating in, because we are all project based. And we have done that quite often, and it's regular as well. So it's very systematic at the same time, project to project basis. So at this, I can talk in Summit, being in Summit, we can host, and I know that for sure all the CGI system can host a student. As a starting point of collaboration. For example, if you send your student to do research here, for example, we can provide our field. That's a land that they can play with. And we have done that even with the DRA, for example, there was short-term collaboration with Grab, still operating by GRA, and one of the initiatives, CGI initiatives called Road Support System Transformation. So we also invite students from the universities in the global south to come to this research institute and learn on the low food system technologies and identifying their business potential. Students, professors in research interest and the interest of the hosting scientists in CGI system matches. We've done that for past 10 years or something like that. That's climate and
Okay.
yeah, climate.
Yeah. So
climate network graduate student. No, it's the network of graduate students under climate network, where it's mainly towards low food system.
We should maybe start small and identify the low hanging fruit that maybe we can already with what we have try to investigate.
So I'm from UC Davis, and as you may know, like the California agriculture heavily rely on the specific crops instead of like the staple crops or annual crops. And actually, our group like is working. So we have finished a study for the climate change impact on environment, and also talking about exploring the potential adaptation strategies. And we will move forward to other nuts and fruit crops. And in case I know the AgMIP, I think mainly focus on those like the staple crops. But if any of you like interested in those like specific crops, and we're happy to talk about like the collaboration.
I mean, since we talk about adaptation needs, and you mentioned Edna's paper,
Yeah.
right, from our group, maybe a question to Christoph from the last days on the global top modelers. I mean, as we stand right now at the global level for the major crops, we don't really see very strong impacts in the median levels, right? I mean, we have rather positive impacts for wheat. We have, what is it, rice and soybeans, more or less close to zero. So if you put that into the large scale models, there's not even a real adaptation need, right? So that's one, I think, still one of the next steps we need to get better at. But I don't know, is there any new, I couldn't follow all the discussions, of course, in the groups, but what's the take on that?
Well, I guess that applies to also many things that were said. We have models that do things, and then how can we trust them? And like we parameterize it somehow, and then we use it, and that's the idea of having a model, right? And then you evaluate your result and think, how can I embed it to kind of improve on or really trust them? Maybe this is true, but maybe this is not true, because there we that's why we have this Monday afternoon session also with the AgMIP10 team, because the AgMIP10 team has actually looked at a lot of processes that are missing in models and tries to develop blueprints for how those could be implemented. And that, of course, is then a charge to lower scale models to incorporate this increasing knowledge and old that exists into that and bring it forward. But also another aspect would be, okay, maybe much of the signal that climate change actually brings isn't the variability. And if you're just flattening it out by looking at 10-year means, then you're missing again maybe an essential part of that. So I think it's a learning process, and it's good. And that is maybe, for me, that's the value of AgMIP to come together and say, hey, I took the data and I get nothing, or I get a worldly word from it. And then we can learn from it and discuss things. Because in isolation, I can only do so much evaluation of my model, because usually like data to evaluate is limited. And then I have to apply it for projections, and then I see something. You have no idea if this is valuable. I mean, the MIP, you see that a very broad range in projections. But in order to improve on that, we need this feedback from others that have a different perspective. And that is, I think, one of the important collaboration opportunities in AgMIP, to have people that work at very local scales, at very specific aspects, look at these global things that will never happen. And then they can explain why they think so. And also the global folks upscaling things and say, well, your global folks in France kind of work like this in Africa. And then you can also discuss about it and kind of try to improve on it. I think that is a process that already exists in AgMIP, but maybe that could be strengthened, like to more strongly expose what people do at different scales to the other scales and say, well, give me feedback. Why do you think this is perfect?
Yeah,
There's one, yeah, because that's completely, I agree, that's a challenge. I would ask back to the more regional to local modelers. It would be really interesting to see studies, and overflow now with all the information over the last 3 days, the studies where you could show for a certain location or so that by leaving out, let's say you want to show a production system which with lower emissions, and it makes a difference whether or not you have the adaptation aspects in there. You know, does the mitigation effort become more difficult if you include the climate impacts at the same time, right? So that you really are there really co-benefits? Because what I can say from the global models, referring to Mario's presentation in the morning, we included the climate impacts from the crop models into these key mitigation studies just for coherence. And frankly speaking, it doesn't make any difference whether we include the crop yield impacts from the latest TGCMI runs at the aggregate level. You know, mitigation doesn't become more challenging if we include the climate impacts on agriculture. That's just what's our current state of knowledge is. But if this is different in certain locations, maybe, I don't know, in Berto, from your studies, that would be very interesting to know, because then it's really interesting to talk about co-benefits, because, you know, there are these double challenges.
Yeah, in that nice that we did in Zimbabwe, the crop livestock system, what we did a set of different strategies. One was, for example, reducing the area for maize and growing mokuna for breeding for cattle, and another set of scenarios. But the point was that when we look at the trade-offs, there were some strategies where you can have the adaptation component, meaning you are resilient to climate change with income and all of that, but then you have large emissions, right? So, but there were some that show actually the co-benefits, that maybe the income was not as higher as the other strategies, but you were also reducing emissions. So then the question was, especially for this small region in Zimbabwe, is does it make the sense to think about mitigation adaptation when it's a small region, right? In terms of the contribution of emissions, does it make sense? Or policymakers should just care about farming livelihoods and try to maximize income, right? So we can see that in that study, for example. So that's one example.
Hey, we have 10 minutes left, but maybe we
Just
some time
respond
also, yeah.
briefly. I mean, regarding adaptation, it just seems like it's so regionally specific. You know, you were mentioning, can you adapt for wheat, but you're going to have areas in the world which will be adversely impacted low wheat, and some which will be fine, and others which you can have a great opportunity. So it really needs to be very regionally specific in which practices apply. Another point to make is regarding the mitigation and adaptation. Certainly, you need to look at them together. But a real challenge is that a lot of the end losses are going to increase under climate change in much of the world, especially if you go to subhumid and humid areas, because you have faster processes, your decomposition, your nitrification, denitrification, everything increases. So you tend to have more leaching, more runoff, more volatilisation, and more into emissions. So I'm just saying that these impacts, these biophysical impacts over time, need to be well captured in models. And it's a real concern, actually.
Yeah, I was wondering the same thing on grasslands and rangelands being whatever percentage of the world's surface under climate change, with the scenarios you've shown there of soil carbon sequestration. Does that factor in warmer climate, which would mean less carbon?
Makes a big difference.
Does it factor in, or how might it factor in the change in like species of forages that are going to shift from C3 to C4, and you know, weeds in some places are going to go into highly productive areas today, which will lower productivity. And like feedback loop, like do the models capture those kind of things on the extent of ranges and grasslands?
Challenge.
Big challenge, but massive scale.
All these end loss components are important economically too. We need to be considered in economic assessment, which is important to link to all projects we can, really.
I don't know how IPCC has done. I've just read that, and I guess, you know, the adaptation and mitigation potential of some of those technologies that are today, you know, for many of them, it would not be there anymore in the future. How they did that, I don't know, but there is around that. And the work that we did in AgMIP, I guess we did a little bit on the future climate, for example, so we could do something like that. So what would be the mitigation potential of the technology that we're testing today in present climate versus future climate? And that can do a range of technologies for adaptation as well as mitigation.
Yeah, I can see. So I think like so for some regions, like I think the adaptation is also related with the competition for resources. Like in California, the water scarcity is a big issue. So like in response to the climate change, like if they need like more water resources, they may need to compete with other like crop growers. And I think like including like the economic perspective is more important because like can they like still achieve profits with like higher like more irrigation requirements and higher water prices? Yeah, I think that's gonna be an issue.
Okay, with time. I think we should come to an end. I think it was a challenging session for all of us, but only because we're already quite tired also. And but I think we all agree that we need to adapt and we need to mitigate and we need to integrate it because I mean that's the solution we need for the future. And so there's the necessity to consider that also in our approaches. I think that's clear for all of us, but it's still not clear how to do that. I think maybe we can identify who is doing what, then look at what has the highest potential. So what is already done, what do we need, and also identify low-hanging fruits, what we could maybe already do. And yeah.
Thinking about what report back to the session. So we had this point that different perspectives, like different disciplines and different scales are important feedback mechanisms that AgMIP could do. I was just thinking if an idea would be that each team in AgMIP has maybe 2 mentors from other teams that are occasionally invited to team meetings and just kind of give feedback from their perspective to the others. And at least I think for us that would be super helpful to just kind of, and it would be a low barrier because you just need maybe 1 or 2 Zoom meetings a year or so where you just kind of go and get back. Maybe that would be something that AgMIP could actually do because it requires low resources and it could also be interesting for us.
It's very good idea.
Very well. Okay. Thank you so much and thanks.
Will there be follow up on this or?
Your report that is, I don't know if there's any, but that was like